Okay, so we've been looking at factors in class, and if you're just watching this and maybe missed a couple lessons, one way of finding factors is to use the visual tool factor trees. You use it to find prime number factors, and then you simplify those prime number factors into index form. And I'll go through what both a prime number and an index form is again, just so that we have the same understandings. So what is a factor tree? So a factor tree is a visual tool used to find the smallest possible factors for a number. So in this instance here, we've got 40, and I guess the thing to remember is that you're going to the smallest numbers because they are only divisible by 1 in themselves. So 2 is not divisible by anything other than 1 and 2. Divisible just means you can divide it. So there are a few tools that we can use when we're doing this as well. So obviously this is a visual tool to help us. It helps us by branching down, guiding us to the smaller factor. Okay, so tools to use when you are looking to make a factor tree. Instead of having a times table chart, it's probably a good idea to have just a list of prime numbers. So in this instance here, this is one I've just found from the internet, and it lists the prime numbers all the way up to 100. Realistically, we're not really going to be using many past, say, 20. So 19 would be your highest one. Times table chart isn't as useful just because we only go to 12 times 12 typically with our times table charts, and that leaves us with only the prime numbers 2, 3, 5, 7 and 11. So that's could be a tool to have something in the front of your book or write it on the side of the page. Another tool would be your calculator, because we're testing whether or not you can find factors, not your ability to do times tables. You can do it by working out the division longhand, but to do that you need to be logical, so you always need to make sure you're engaging your own brain. So these are the tools you should have with you at all times. And okay, so for this one here we have got factor tree for 40. We had a factor tree for 40 before. This is going to be this. Essentially, you're going to get the same numbers out of it. So the other one before had 3 2s and a 5. It just had it in a different order. So the 10, instead of being in the middle, ended up being down on the side. And that's okay. Your factor trees are going to be slightly different, but what we need to remember is that this index form is going to end up being how we simplify our answers. So 2 occurs 3 times, so it would essentially be 2 times 2 times 2 times 5. And so we can write it as an index where our base number is 2 and our index is 3, and we multiply it by 5. Then you could have done it a different way. You could have, instead of doing 2 and 20, you could have done 4 and 10, and then it would have been 2 and 2, and then 2 and 5, and that's acceptable too. Just remember that then you're still going to get this as your simplified index form, 2 to the power of 3 times 5. So just to illustrate that, here we've got 72. Now 72, a lot of people, when they think 72, they think factors of 6 and 12, because that's the first time it kind of appears in our times tables, so we think of it that way. It could also be 8 and 9, and it will give you the same index form simplification. So if you look, we've gone 6 and 12 on both of them, and then it branched differently. So how do we do it? All right, so if we have the number, sorry, just trying to find my pen. We have the number 48. The first thing I notice about this is that it is an even number. So I'm going to take a 2 out, and that leaves me with 24. 24, you could have 3 and 8. you could have, so we could do 3 and 8. Let's do 3 and 8. And then you're going to end up with 2 and 4. And then you're going to end up with 2 and 2. So your index simplification for this one would be 1, 2, 3, 4. So 2 to the power of 4 times 3. Another way of doing it would be to go, okay, we've got 48. And again, we can just go, well, that's clearly going to be 2 and 24 because it's an even number. And then I know that 24 is 4 and 6. So 4 has the factors of 2 and 2. 6 has the factors of 2 and 3. And again, we get 1, 2, 3, 4 2s and 1 3. So our index form would be the same. Let's try it with 120, and it might be a good idea, 126, sorry. It might be a good idea to pause it here and try it yourself and see where you get up, remembering that the index form is the important part, not the order that you get it in. So pause it now, or if you want, just pause it after I've written that. So you're always going to only have the 2 branches. So pause now and try and solve it yourself. Now, hopefully you've paused it and tried it yourself. And now you're going to go, okay, well, it's an even number. So I'm going to go 2. And 2 goes into 126, 63 times. Okay, so you can do that longhand. So I'll do it longhand here. Okay, it doesn't go into 1, but it goes into 12 6 times with no remainders, goes into 6 3 times, which gives us our 63. Again, I look at the number and I think, where have I seen that on my times tables? And I have seen that on my times tables as 9 and 7. 7 is a prime number. There's nothing more I can do to it, but 9 has the prime factors of 3 and 3. So the index form for this would be 2 times 3 to the power of 2 times 7. Try one more. 120. Now, 120, again, remember that you only ever have 2 branches at any one time. Pause it now, try and solve it yourself. Hopefully you paused it. I'm going to say, well, I know that 120 is an even number, but I also know that it is in the 12 times tables, and it is 10 times 12. The reason I chose 10 is just it gets rid of that 0, makes it a bit easier to deal with. 10 has the prime factors of 2 and 5. 12, we can go 3 and 4, and then 2 and 2. So again, pause it, try and work out what your index form solution would be. So 2 appears 3 times. 3 appears once, as does 5. So hopefully that's been helpful in finding prime factors. Remember that you can always watch it again. You could email or put a comment up if you need to, or if you're one of my students, you can talk to me in class.